Have you ever stopped to think about what a giant supercomputer, your car's GPS, and, I don't know, your smart coffee maker all have in common? I know, it sounds super complex, but really, it all boils down to this secret code. Just 4 fundamental principles that every single one of these devices follows. So, let's dive right in.
Okay, so let's kick things off with a question. What do your smartphone and your thermostat actually have in common? I mean, on the surface, they're totally different, right? One's this little supercomputer in your pocket, the other just, stops you from getting cold. Well, the answer is way simpler and honestly way more profound than you might think. They both speak the exact same language.
And that language, it's built on just 4 basic operations. We're about to pull back the curtain on the secret code that powers literally every piece of tech in our lives. Understanding this is kind of like getting an all-access backstage pass to how the entire digital world works. All right, you ready? Here they are: input, processing, output, and storage. Seriously, that's it. This is the foundational rhythm, the core blueprint that everything else, from sending a text message to launching a rocket into space, is built on top of. So, let's break each one down.
First up, we've got input. The easiest way to think about this is like a computer's senses. It's how it listens to the world around it, how it takes in information and commands. Without any input, a computer is really just a useless box waiting for someone to tell it what to do.
And what's so cool about this is that you already know all of this stuff. I mean, look at this list: typing on a keyboard, clicking your mouse, tapping on a touchscreen, yelling at your smart speaker to play a song, yep, even a little sensor that just detects the temperature. Those are all different kinds of input. They're the bridges between our world and the machine's world.
Okay, next up is processing. And this is where the real magic happens. It's the brain of the operation. It takes all that input it just received and actually does something with it. It calculates, it analyzes, it makes decisions. And the hero of this whole stage is the CPU, the central processing unit.
And look, don't just think of this as doing math. Processing is so much more than that. When you slap a filter on a photo? That's processing. When your computer plays a video for you, that's processing. When a character in a video game decides what to do next? Yep, that's processing too. It's literally the thinking part of the cycle. All right, so the computer has taken in the information, it's done its thinking. Now what? Well, it's got to communicate the results. It has to talk back to us, right? Well, that's output. It's how the computer shows us or tells another device what it came up with. And this is just the other side of the coin from input. Think about it. The words you're seeing on your screen? That's output. The music coming from your speakers? Yep, output. That physical piece of paper that comes out of a printer? You got it? That's output too. It's the final, tangible result of all that thinking.
And last but not least, we have storage. This is the computer's memory. I mean, a computer that can't remember anything would be pretty useless, wouldn't it? Storage is what lets a computer save data, whether it's just for a split second or for years and years.
Now, storage isn't just one thing. It really breaks down into 2 main types. Think of temporary storage, or RAM, like the stuff you have out on your desk. It's right there, it's super fast to grab what you need, but when you turn the power off, poof, it's all gone. That's why it's called volatile. Then you have permanent storage, like a hard drive or the cloud. That's your filing cabinet. It holds onto your files and photos forever, even when the power's off. You absolutely need both to get anything done.
Okay, so we've got the theory down. Let's make this real. Remember that thermostat we talked about at the very beginning? Well, it's actually the perfect no-frills example of all 4 of these operations working together in perfect harmony. So let's trace its thought process. First, input. The thermostat takes in 2 pieces of information: the current temperature from its sensor and the temperature you want it to be. Next, processing. This is super simple. It just asks one question: is the room colder than the desired temperature? If the answer is yes, then comes the output. It sends a command to the heater to turn on. Simple as that. And if you have a smart thermostat, it might use storage to remember temperature patterns over time. See? Input, processing, output, storage. It's all there.
Okay, now that you're in on the secret, let's have a little fun with it. It's time for you to put on your technician hat and play detective. Because knowing these 4 steps isn't just trivia, it's an incredibly powerful tool for figuring out what's wrong when your tech starts acting up.
All right, scenario 1. Picture this. A manager has a super important report all ready to go. The computer has done its job, the file's all set, but every time they try to print, the printer just keeps jamming. So, which one of our 4 operations is the problem here?
So what do you think? Is it A, input, B, processing, C, output, or D, storage? Just think about where in the cycle things are going wrong. The information is all there, It just isn't being delivered.
If you said C, output, you absolutely nailed it. A printer's entire reason for existing is to be an output device. The computer already sent the data over, but the final delivery, that physical piece of paper, is failing. See how simple that becomes when you break it down?
Okay, ready for round 2? Imagine you're at a hotel and there's one of those fancy touchscreen kiosks. The screen itself looks great. It's showing a map, all the info's there. That part's working perfectly. But you go to tap on it to pick something, and nothing happens. What's the issue?
So what's the culprit? Is it input, processing, output, or storage? Where's the fail point this time?
And the correct answer is A, input. Think about it. The output is working like a charm. You can see everything just fine on the screen. The problem is, the device isn't listening to you. The touch screen, which is an input device, isn't registering your touch. It's an input failure.
So let's just zoom out for a second. What we've seen is that it really doesn't matter if we're talking about a simple thermostat or the most advanced AI on the entire planet. The core logic is exactly the same. It takes in information, it thinks about it, it gives a result, and it remembers what it needs to. These 4 simple steps are the universal building blocks of our entire digital world.
I want you to really let that sink in for a moment. Input, processing, output, storage. It's not just some list of terms from a textbook. It's the foundational rhythm, kind of like the heartbeat of the entire digital world. It's the simple, elegant engine that drives absolutely everything.
And that just leaves us with one last question to chew on. We've seen how these 4 simple steps can power something as basic as a thermostat. We know they power our phones and our laptops. The real question, the really exciting question is, what are they going to power tomorrow?